Hello everyone, I'm Jerikah. So for today's discussion, we'll be doing a sample problem on solving for resultant vectors. So we'll be using two methods. First is the graphical method, and second is the component method. To start, let's first try to solve our sample problem using the graphical method. Here is our sample problem. A soccer team is training and doing some passing drills. Player 1 passes the ball to player 2. Player 2 passes the ball to player 3, and so on. So what is the resultant vector? So when doing the graphical method, we start off by drawing a blank Cartesian plane. Then we try to graph our very first vector, which is 7n, 25 degrees east of north. And we'll be placing our protractor vertically, since we'll be finding east of north, which goes from this direction to here. Now once we place our protractor, we'll now find and place a dot on where 25 degrees east of north is, which is over here. I've already placed a dot, but let me highlight it more. Over there. Now that we placed our dot, we can measure out the distance using a ruler with the centimeter side. In my case, my ruler is in millimeters, but it can be converted into centimeters since 10 millimeters also equates to 1 cm. So yeah, we proceed with measuring out 7n. For this, you'll just draw a line from the center of your first Cartesian plane that's as long as 7 centimeters. So from this point all the way to here. And then once you've drawn your line, we then label this as our very first vector. And I put P1 on mine to signify player 1, and alongside it, I put the magnitude of the given. And at the very end of our line, we draw another Cartesian plane. And we'll just be repeating the same thing we did earlier by finding the angle, then measuring out the distance using our ruler. For P2, the given is 4n, 10 degrees west of south. Since it is west of south, we place our protractor vertically again, but this time facing west. And west of south goes from this direction to here. And then we place a dot where 10 degrees west of south is, which is also over here. I've already placed a dot, but let me highlight it again, which is over here. And we draw another line from the center of our plane that's as long as 4 centimeters. Then here is our second vector. And we just label it again. From this point, simply repeat the process and draw a Cartesian plane. Again, find the angle for P3, which is 35 degrees east of north, and we place our protractor vertically and find the angle 35 degrees east of north, and place a dot over here. Then measure out a 5 centimeter line from the center, and here is our third vector. Right at the point of our third vector, we just draw another Cartesian plane and repeat. Then for player 4, we plot out where 15 degrees west of south is using a protractor, which is right over here. And once we plotted out where it is, we draw a line that's 6 centimeters long, like this one. And here we have our fourth vector. We just draw another Cartesian plane again. And lastly, for our final vector, this time the angle is 45 degrees north of east. So we'll be placing our protractor horizontally, since north of east goes from this direction to here. And we just plot out where 45 degrees is, which is over here. And once we plotted out our point, we just draw another line that measures for 3 centimeters. And we finally have our last vector. And you just label it as well, just like what we did with all the other vectors. But we are not done yet, as we have to measure out the result vector from the very first Cartesian plane to the last one we made. So what we'll be doing is we'll draw a line from the center of the first Cartesian plane and we'll be measuring out the length using our ruler. As we can see, the distance roughly measures out to 6.3 centimeters. And once we have that down, we can measure the angle by placing our protractor on our very first Cartesian plane, and we try to identify the angle of the line connecting the first and last points. As we can see in our picture, it measures out to about 26 degrees northeast since our protractor is placed horizontally. And we finally have our resultant vector for the sample problem. So our final answer is 6.3 n at 26 degrees northeast. As you can see, using the graphical method makes it sort of easier for you to be able to visualize the problem or the situation, though it is not exactly as accurate as the next method we're about to do, which is the component method. So for the component method, there's much less graphing here as it's more mathematical, since we'll be using equations and our calculators to solve for the resultant vector. And the first thing we should do when using the component method is to make a table and input all of the given accordingly. So in the leftmost column, we'll put our magnitude and direction, and at the right, we'll solve and input the x and y component. The formula we'll be using to solve for these components will be listed down below for your reference, and there are actually two sets of formulas that are used depending on the given reference angle. If the reference angle is situated at the x-axis, the formula for the x and y component would be this set of formulas. If the reference angle is situated in the y-axis, we'll use the other set of formulas, which are these ones. So as we can see for the first four given, our direction points to east of north and west of south, which are along the y-axis, meaning we'll be using these sets of formulas to solve for the x and y components. You can input these equations into your scientific calculator to find the answers, though I've already shown the answers, but you can still double check if you'd like. And for the very last given, the direction is north of east, which means that we'll be using the other set of formulas to find x and y, since the reference angle is along the x-axis. Again, input it in your calculators and we'll get the answer 2.12 for both components. And after we find both x and y components, we can now find the sum of both columns by adding them together. So for x component, we have a summation of 5.71, while for y, we have 2.82. To solve for the resultant vector using component method, we just take note of the given and the formulas. So here is the formula for the resultant vector, and we'll simply input what we've solved earlier in the previous slide, which is 5.71 and 2.82 in their respective slots in the equation. Again, you can just input this in your calculator and you'll be able to get 6.37n. As for the direction, here is the formula. Same thing, we'll just substitute our answers earlier to the given formula and input it in your calculator, giving us an angle of 26.28 degrees. Our final answer for this equation is going to be 6.37n at 26.28 degrees north of east. And we got north of east because both of our summations earlier were both positive. So if we compare our graphical method and component method answers, as you may have observed, the answers are quite similar with little difference only, though the component method is probably much more easier and precise when it comes to the final answers. So that is it for today's problem solving activity. Thank you so much for listening, and I hope you learned a lot. Goodbye!